In this lecture, we'll look at the relationship between pointers and arrays in C. And we'll see that although pointers and arrays are distinct ideas, C allows indexing of pointers in a way that makes a pointer behave very much like an array. In our example for the example program for this lecture, we have a 5-element array, int array, and an int pointer, iPointer. And we'll assume throughout the discussion that int array starts at address 4000. Our program will ask the user to enter 5 elements for the array, and then we'll square the values of each just to have something to do with them, and then print the resultant 5 elements back out, as the sample run down here shows. And it will do so without once indexing int array. Instead, we'll do all the work on int array through pointers. Adding some line numbers to our code here, let's look at line 28. This assigns int array into iPointer. But note the lack of an ampersand on int array. The name of an array by itself, without indices and without ampersand, stands for the address of the array's first element, with no need for an ampersand, as the comment in the code here indicates. So line 28 assigns the address of int array 0 to iPointer, as the diagram now shows. We'll even enter in a 4000 to be explicit about that in iPointer. Each element of int array is an int in its own right, by the way, and thus it has an address. So nothing prevents a pointer from pointing to just one element of an array, or as we'll see later, to just one field of a struct. So what's the difference between iPointer pointing to the first element of the array versus just pointing to the entire array? The first element and the entire array have the same starting address, right? So can't we view iPointer as pointing to either one? We will encounter pointers a little later on that have an entire array as their target, but iPointer is not one of them. It's declared as a pointer to an int, and thus its target is always just one int. In this case, the first int in an array. This is a good example of the importance of a pointer's type. The pointer's type determines what type of target it has, and thus whether it points to just one int or an entire group of them. So remember this rule. The address in a pointer tells where it points to. Its type tells how much it points to. The target type of a pointer will become even more important when we start doing pointer arithmetic in just a moment. So let's look now at the while loop starting on line 31. This loop reads an int into each element of int array using iPointer to walk down the array. Ignore the loop test for a moment. We'll get back to that. The scanf on line 32, however, reads an int into the target of iPointer, which at present is the first array element. Recall from prior lectures discussions on why we don't need an ampersand in that scanf, by the way. So a 0 from the input goes into int array 0, as you can see. But line 33 is the really interesting one. Can we increment a pointer? Yes, and the effect is almost what you'd expect. The address in the pointer increases, but not necessarily by 1. It increases by 1 target size. In our diagram, for instance, int array bracket 0 is at address 4000, and int array bracket 1 is at address 4004, assuming 4-byte integers. Incrementing iPointer increases iPointer by 4 bytes, not 1. So it points to int array bracket 1, as the diagram, if we can get there, will show. Thus, when you consider it, this is the only sensible thing to do. Increasing iPointer to, say, 4001 would point it about 1/4 of the way into int array bracket 0, which is hardly useful. We're about to encounter a variety of different pointer arithmetic operations like this increment, and they all follow the same principle. Pointer arithmetic is always in terms of the size of the target, adjusting the pointer's content by some number of target sizes. So with this we can see that the while loop advances iPointer down the array, one element at a time, and that the scanf reads integers into successive elements of the array. Thus, now question 1 here, just to emphasize that increasing I-pointer to 4004 would make no sense, to 4001 would make no sense. Ask yourself what would happen if you did increase it thus, and then dereferenced it to get the int that started at 4001. Pause and think. Coming back from the pause, the result would be a bus error, because an int cannot begin at an odd address, per the discussion in prior lectures. So, the only question that remains is, how do we end the loop? We want to do this when I-pointer is pointing past the end of int array to what would be int array's element number 5, or 6th element, as shown in the diagram. So question 2, what address will be in I-pointer at that point? Pausing and thinking about it, coming back. I-pointer at that point will contain 4020, 5 integer sizes in from the start of the array. So what do we get then from I-pointer minus int array? The immediate answer of 20 is incorrect. Consider the above rule regarding pointer arithmetic and target sizes, and then make a guess as to what the difference would actually be. Going back from a pause there, we'll get 5, which is the number of integer sizes between the two addresses 4020 and 4000. All pointer arithmetic, including subtraction of two pointer or address values, is in terms of target sizes, so pointer subtractions are automatically divided by the target size. Pointer subtraction is allowed between any two addresses or pointers, provided they are of the same type. And again, this makes sense if you think about it. The subtraction is in terms of the target size, and so we need a clear target type, and thus both operands must have the same type. Here's a summary of pointer arithmetic rules then, finally. You can increment or decrement a pointer. Doing so increases or decreases it by one target size. You can add or subtract an integer value to or from a pointer. You can say, for instance, I-pointer minus 10 or plus 5. As in all other cases, the addition or subtraction is in terms of target size. So I-pointer minus 10 would compute an address 40 bytes less than I-pointer. And then finally, subtracting two pointers or addresses from one another is allowed if they have the same type.